I'm Jamie Waterman.
And I'm Caitlin Broman, and we worked on the greening of the Rubenstein Ecosystem Science Laboratory. Our main objectives included improving the building's energy efficiency through utility upgrades that reduce energy consumption.
We were provided with a high-level energy audit
by Slade Engineering,
along with UVM's physical plant director, Richard Walbach, with the help of Dean Matthews, Gary Howley, and other crucial faculty members. All upgrades were approved and are to be implemented in the near future.
In this day and age, it is imperative that we reduce human impact on our planet, conserve our resources, and minimize our emissions. By installing the suggested upgrades, UVM will not only save money, but will significantly reduce electricity, natural gas, and fossil fuel consumption, therefore decreasing its ecological footprint.
We believe as Rubenstein students, it is our responsibility to spearhead movements of environmental conservation and stewardship, which is why we are so excited to see this project come to life. One of the first things we did, using the School Dude database, was calculate the current annual average electrical usage in kilowatt hours, as well as natural gas usage in 100 cubic feet. Using the audit, we were able to calculate projected usages pertaining to electricity and natural gas. We then compiled the data of current energy expenses, and again, using the audit, we're able to come up with a solid estimate of potential savings. This data was then used to promote the installation of suggested upgrades.
It is important to note that of the total amount spent, approximately 40% will be reimbursed back to the university.
Things have relatively short payback times, and the amount of money saved in the future way outweighs any initial amount that we're going to commit to the project now.
The Rubenstein Ecosystem Science Laboratory was built over 15 years ago and still contains most of the original utilities. On the first floor, all of the rooms are fixed with 30-watt light bulbs, and with the suggested upgrades, we plan on installing new bulbs with a wattage of only 13.
Put in more of a fixture that's LED that will be half the wattage.
If you'll notice the porthole light fixtures, those were installed to prevent breakage, and with all the light bulbs on the walls, we're going to continue with that design. On the first level, there are occupancy sensors in all of the room that are triggered to go off after 30 minutes without movement. However, the second floor is equipped with daylight sensors to counteract the motion sensor. Therefore, if daylight is sufficient enough, even if there is activity in the room, the lights will still be automatically turned off. Each laboratory is currently equipped with 32-watt light bulbs, and the suggested upgrades look to convert the 32 watts to 14 watts. And those consist of two different brands, one being Remfoss and the other being Philips. 2/3 of all energy consumed by the Rubenstein laboratory is due to air ventilation. The largest energy-reducing component amongst the proposed upgrades stems from the two HVAC systems, designed to significantly decrease airflow rates and system pressure.
Right now, we're just ventilating the space. No one's in here. And this building was designed with that sensor to have occupancy and unoccupancy set points.
Currently, when the rooms are occupied, the HVAC system allows for 8 air exchanges per hour, and when they are not occupied, it only allows for 4 air exchanges in order to conserve energy. With the suggested upgrades, it would be possible to do this more cost-effectively.
All of the spare parts extracted from the Rubenstein lab will be recycled for further use throughout the UVM campus.
The HVAC side, the air side of the building, there were some initial issues with ductwork on the supply and return air that was going to be addressed. There's going to be upgrades with the air exchange rates associated with the labs that we'll be able to set back based on occupancy.
After completing the tour with Richard Walbach, we were able to see firsthand some of the issues regarding excessive energy consumption. The main issues concerning energy usage were found in the processes of air ventilation.
The HVAC fans, who would have thought that the lack of a timer was a really huge issue?
With that being said, the most crucial aspect of the energy audit was the heating, ventilation, and air conditioning system also known as HVAC.
Energy conservation measures that I really was instrumental in would be the ones that have to do with that fan energy. So it's line item 2 right there, right, 102, which is the overall reduction of airflow in the building.
The fact that it was an issue that the class identified and the administration listened to and hired a firm to go in and do an analysis, and they came back with the results, and the university is going to listen. You know, we're going to do it.
We should maybe be doing this to every one of the buildings. And I know the university is doing that when they have the resources. They're doing audits of all the buildings.
Rubenstein is a model right now of what we're going to be doing campus-wide. And like I mentioned to your team before, that we're also working on Waterman and Colchester Research Facility, and we'll be doing further deep level engineering by way of using the matrix type format on subsequent buildings like Rubenstein, Waterman, Colchester Research, and then we're going to continue on as we can, as funding allows us to. And we do have a green revolving fund that can help support us with those ventures as well.
We should all be aware of our energy usage in order to increase the longevity of our planet. The suggested upgrades for the Rubenstein lab are a prime example of ways we can reduce our ecological footprint and should be an example for buildings campus-wide. We both thoroughly enjoyed working on this project, and we'd like to thank all faculty members who helped us, specifically Gary, Rich, and Dean Matthews. We can't wait to see the final product.